Hello once again. This is the Pencrest High School AP Physics 1 video series. This is video 7A, Introduction to Rotation. So up until now, the motion we've looked at has been what we call translation. That is motion along a straight or curved path. Rotation refers to an object that turns or spins around a fixed axis. Fixed means that the axis itself does not move. Rotation has some similarities to circular motion, and we'll see some situations where they both apply. But it must be emphasized that circular motion and rotation are entirely different motions. You might recall during the circular motion unit, we looked at a Ferris wheel. And in that unit, we focused on the cars themselves. So when we looked at the car here, as the Ferris wheel turns, the car moves through circular motion. The entire wheel, however, undergoes rotation and spins around an axis that is in the middle here and points out of the screen at you. We can also illustrate the contrast in the two motions with the Earth's major motions. The Earth rotates on its axis once per day. If you look at the picture here on the left, here is the rotation axis. The Earth spins around that axis once a day. That's the motion we're looking at for the time being. We can also look at the Earth's motion around the sun. This is the circular motion around the sun. We've already looked at that. So again, we're contrasting the two motions. This unit, we're looking at the rotation of the Earth on its axis. Now, we've looked at, up until this point, 4 major content areas of mechanics. We've looked at kinematics in 1 and 2 dimensions, or motion, of course. We've looked at Newton's laws, which attempt to describe why an object is moving a certain way. We've looked at work and energy, and we've looked at impulse and momentum. You can make a case for circular motion as well, but that actually falls under kinematics and Newton's laws as far as we took it. Each of these major content areas has a rotational analogy. So we'll look at the kinematics of rotation. We'll look at Newton's laws for rotation. We'll look at rotational work and energy, and also angular momentum. In each case, the information that's revealed by the analysis is very similar in both translational and rotational motion. Just as translational kinematics tells us where an object is and what it's doing at a particular time, rotational kinematics will do the same. We'll see rotational analogies for position, displacement, velocity, acceleration. Their basic definitions are the same, but we replace the distance measurement, which is usually meters, with an angular measurement, which is typically radians. We can also look at it with degrees or rotations. We'll take a much closer look at that later. We know that Newton's laws tell us why an object is behaving a certain way kinematically. Also in rotation, we use net torque instead of net force, but the idea is the same. Torque is the tendency to make an object want to accelerate in a rotational sense, makes it want to rotate or twist, just as force makes objects want to accelerate in a linear sense. Work and energy represent an alternate analysis that'll focus on energy added or removed from a system, just as before. The energy we focus on will be rotational kinetic energy. We remember kinetic energy is energy of motion, but that motion is rotational instead of translational. The premise is still conservation of energy, so we'll look at the energy at A and the work done and the energy at B. when we look at objects, systems of objects that can rotate relative to a fixed axis, we will then look at the angular momentum of the system, both in cases with multiple objects and also single objects that change their distribution of mass. We'll take a look at a figure skater that goes into a spin and pulls the arms into the middle so that they spin faster. Again, we're going to hit all this stuff later, but the key premise is that all of the subject matter that you've looked at in a translational sense will have an analogy in the rotational sense, and a lot of the language is the same, a lot of the analysis is the same. So there's a little bit of everything here, and again, opinions vary about rotation. Some people describe it as the toughest unit of the year. I think that's because there's so much material in it. Hopefully, if you've internalized some of the stuff from earlier, hopefully it'll come back to you relatively quickly. So, all right, that's it for the introduction. We'll move on to kinematics. Until then, I'll see you again soon.